So here's our first sealed room scenario. As you can see, we have a reflector that is not air-cooled. Monster Gardens recommends that gardeners use mini-split air conditioners and not portable ducted air conditioners, as the portable ducted air conditioners are highly inefficient, don't do a great job of cooling the room, and they're really only good for low wattage lights, single light gardens. So here in this diagram, we show you the single light, non-air cooled, sealed room with the mini split air conditioner, as you can see on the top in the middle of the room. Now, as we stated in our previous video, we do recommend one oscillating fan or more per light. Since it's a sealed room, there is no fresh air coming in. So the plants are literally consuming all of the CO2 in the room, and it needs to be replenished. So as you can see, on the bottom left side of the screen next to the oscillating fan is a CO2 tank. We prefer gardeners use CO2 tanks as it doesn't create more heat in the garden as CO2 generators do. So on the bottom right side of the room, what you'll see is what we call a carbon scrubber. It's literally a fan on top of a filter that's taking the unfiltered air through the bottom of the filter, blowing the filtered air through the top of the fan, basically scrubbing the room for any scent or smell, so it can eliminate most of the scent and smell of your garden. Now, a more efficient way of running a scrubber would actually be to take some ducting off from the top of the fan and maybe run it to the other side of the room. That way you're getting a full air exchange, scrubbing the entire room. We didn't add the ducting in this picture. It wouldn't look very good in the picture, and it might block some of the equipment. Now, in this room, there is one component that's missing, a dehumidifier. In a sealed room, it's essential that you have a dehumidifier. Now, when the lights are on, the air conditioner is going to be running. Air conditioners actually dehumidify air as they cool. So the dehumidifier is really used when the air conditioner is not on, which is typically during the dark cycle. As you can also see, we have a very simple grow system in here. This is a hand-watered system. So this would be a system you would be hand watering with pots and saucers. Any kind of system could be in this room. We're just showing you a simple grow room system in this example. So here we have our second diagram showing you two non-air-cooled reflectors. These are actually Gavitas that we put in here. This is a very popular, highly efficient grow light that we've been selling a lot of. As you can see, we have our carbon scrubber centered in the middle of the room with their filter and fan. We have our CO2 tank on the bottom left of the room, and we have our dehumidifier, which we had missing in the first room example, on the bottom right of the room. So let's talk about some efficiencies here. As you can see, we're using two non-vented reflectors or non-air-cooled reflectors. The reason why a lot of gardeners choose to use non-air-cooled or non-vented reflectors is because when you put glass in front of a bulb, it's going to decrease the light output 5 to 7% right out of the gate. Because of this, it is shown that air-cooled reflectors decrease light output right out of the gate. So efficient lighting systems are not going to use air-cooled reflectors. In this situation, all you need to do is get the proper conditioner or mini split in order to compensate for that wattage of lighting. Another efficiency that we're showing you here is a CO2 tank instead of a generator. The generators are going to create as much heat as 1 to 2 more grow lights. So that's a lot more cooling capacity you need to be able to compensate for. Because of this, we do recommend CO2 tanks over CO2 generators. Now the dehumidifier on the right, as we stated in the video before, because mini splits and regular air conditioners typically dehumidify the air as they're cooling, you really only need to run the dehumidifier most of the time when the lights are off. If you have a room that has an aeroponic system or a highly evaporating system, you might need the dehumidifier with the lights on. And again, with your carbon scrubber or your room scrubber, you typically run a little bit of ducting off of the top of that scrubber where you see the red arrows coming off. And you would run that to the opposite side of your room to force a larger air exchange before the newly filtered air is recycled back into the filter. And let's talk about a little bit of efficiency when it comes to lighting. Now, a lot of gardeners have heard the statement that your lighting needs to be 18 to 24 inches above your plants. And the truth is that that is the case. Of course, the reflectors in this diagram are much higher just because we're trying to show you all the equipment in the picture without anything blocking. But what we've heard from is a group of customers that use air-cooled reflectors and haven't tried non-air-cooled reflectors, and what they tell us is they're able to bring the reflectors closer to the plants. So regardless if your lighting is air-cooled or not, what lighting engineers and plant researchers have found is the plant can only process so much light. They have a chart that will actually tell you at noon at the equator what the intensity of the light would be, the sun's light would be. And to equate that to a garden with a 1,000 watt light, that ends up being 18 plus inches above the plants. And with a 600 watt light, it ends up being 16 inches plus above the plants. Anything more than that is more than the plant would naturally be able to process. So if you're running these larger air-cooled reflectors such as Raptors or Magnums, I would like you to get actually a light meter and do a little bit of a test and raise that reflector up, because what we're seeing is a big movement in indoor gardening where people are moving more towards the greenhouse mentality, which is light efficiency. So we're seeing people using smaller reflectors, non-air cooled, with more of a focus intense beam to get more depth penetration. They're raising these reflectors up, and the intensity is actually showing to be greater than a larger Magnum or Raptor style reflector closer down to the garden. So just want to give you guys that information. And here we have our third room type, which is air-cooled reflectors, independent air-cooled reflectors, where the air is coming in through the outside wall, in through the reflectors, cooling them, then out through the other wall, where the air is never actually touching the room that's air cooling the reflectors. Because it's a sealed room, we of course have a mini split and a carbon scrubber in the base of the room. Then we have our dehumidifier on the right side of the room and our CO2 tank on the right side of the room as well. Now, in all of our diagrams, we show you the CO2 tank, but we definitely don't show you the CO2 distribution line. You would typically be using a 1/4 inch line that would go to the top of the room because CO2 actually drops. So you would run a line around the top of the room, kind of like a sprinkler or drip system, but it would literally just be leaking the CO2 gas from the ceiling, and it would be dropping down through the canopy of your garden. CO2 enrichment is typically at the level of 900 parts per million up to 1,200 parts per million. Though we know gardeners go to 1,500 parts per million, it is more typical to be between the 900 to 1,200 parts per million for CO2 enrichment. Relative humidity is going to change from flower to veg. Flowering, you're typically going to be 45 to 50, and vegetating, if you're propagating, even higher, maybe as high as 65. The advantage that you get of air cooling your lights independently from the grow room in a sealed room is that you can actually sometimes use a smaller air conditioning system to be able to do this because you're not having to air cool the environment so much. But what you're losing is the efficiency of the non-air cooled lighting, where the glass of these reflectors are actually going to filter out some of your lighting, about 5 to 7%, but it's also going to filter out some of the UVB. And what gardeners know is that UVB is a spectrum of light that is utilized for essential oil production. So if you have botanical plants or plants that create essential oils, you might want to try not using air-cooled lighting to create the best possible production. And in this diagram, what we're actually showing you is a flood table, two flood tables. And because we have two lights, we of course have two oscillating fans. There can be any type of system in this room. The grow system is never particular to the room. We're just showing you a little bit differences from one diagram to the next of what gardeners would do. A lot of gardeners ask us if a hydroponic system is going to get them more yield. And the truth is, we don't necessarily see this. What we see is faster vegetative times. So you can essentially maybe get one more crop a year by using a hydroponic system versus a soil or cocoa organic style system if you do not have a vegetative room. If you have a vegetative room that's separate of your flower room, you're actually going to come out in about the same of having a hydroponic system versus a simple hand water soil or cocoa or even an organic style system. So what we're going to show you here is a switch over to a simple hand water system with the exact same room. As you can see here, we just have pots and saucers on the ground. This gardener would be hand watering the system. This might be an organic system, or it could be called what we say mandro, which is a man-feeding, non-automatic hydroponic solution that they're feeding the plants. So here we have two grow tents in one grow room. This might be a perpetual harvest type of situation, might be a veg room and a flower room type of situation. But what we have here is two independent grow tents in one grow room using air-cooled lighting that is independent to the room, where the air is flowing in from the right side to the left, out through the left side of the room. With the air-cooled feature of the lighting, the air is never touching the room. So what we also have is a carbon scrubber in the top of the room. Now this inline filter is being utilized as a carbon scrubber, and of course would be parallel to the ceiling. We couldn't show that in the picture because it's a 2D picture, but that inline filter in the very top would actually be parallel. So here we have the hot air moving in through the duct line from the top of the grow tents. You always want your hot air to be exhausted out through the ceiling or the top of the grow tents because hot air rises. So the hot air would be going through the ducting, joining to the one single inline filter that's acting as a carbon scrubber through the room. The carbon scrubbed air is feathering out through the ceiling, and then the mini split air conditioner that you can see behind the grow tents on the center of the wall is going to be cooling that hot scrubbed air. So here we have a CO2 tank in the bottom right side of the screen, and as we stated in the diagram before, you would actually have a 1/4 inch CO2 line that would go above that tank that would circle around the top of each grow tent. Because CO2 is heavier than air, it's going to drop, so your CO2 distribution line should always be at the top of your garden so the CO2 is dropping through your canopy. And here we have our dehumidifier at the bottom. The dehumidifier is obviously going to be on when the grow lights are off because the mini split won't have the opportunity to dehumidify the air. As we stated in the previous diagrams, air conditioners dehumidify the air naturally, but the dehumidifier is going to be there when the lights are off, of course. And even if the lights are on, if it's a high humidity environment anyways, the dehumidifier is going to be there in every type of sealed room situation. Now the grow tents are open, as you can see. The grow tents are simply open in this picture so you can see inside the grow tents. And as you can see, there's an oscillating fan for each grow tent. We do recommend at Monster Gardens that you use box fans instead of clip fans inside of grow tents. The box fan would actually be hung in the corner of the grow tent, and because box fans have such a large blade, you can actually put them on low and get a great amount of air movement in the grow tent versus using multiple clip fans. Now most grow tents or grow boxes actually have vents in the bottom of them. Because this is a sealed room, we don't have an airline going into the bottom of the grow tents. We're assuming in this picture that the vents are open at the bottom of the grow tents. There's no filter on the bottom of the intakes of the grow tents on the intake type of situation because, again, this is a sealed room, so we shouldn't need there to be a filter going into the grow tents as the air is being constantly scrubbed. Now in a grow room scenario like this, you can of course have non-air cooled reflectors inside these grow tents. You would typically be using a lower wattage if you're in a smaller grow tent. So if you're in a 3x3 or a 4x4, you're probably only going to be using a 600 watt light. And in a 4x4 or 5x5, you can of course use a 1,000 watt light. In a 4x4, because it's a smaller space, you might not have a tall hydroponic system because you need that distance of 24 inches in between the top of your canopy and your grow light. So just understand that if you're going to be using a higher wattage non-vented reflector in a really small grow box or grow tent, you're typically going to have a low profile system so that you have more of a height capability, so you can create that distance between the bottom of your high intensity reflector and the top of your canopy.